This car is a time bomb. X28 is packed with £500,000 worth of high technology, and it could blow up at any time. This is the story of what it takes for a car to survive the greatest motor race on Earth, the Monte Carlo Rally. X28 has a lightweight engine that's strong enough to cross mountains, a gearbox that changes in the twinkling of an eye, and enough sticking power to cling to the road within an inch of destruction. But all this technology is set to self-destruct in just 3 days' time, a sacrifice to the goal of breathtaking speed. Win or lose, X28 will meet its end on the streets of Monte Carlo. The story begins far from the mayhem of Monte Carlo, because the true heartland of motorsport lies in the leafy English countryside. And this modest façade in Banbury near Oxford is the gateway to every boy racer's dream. In these workshops, cars designed for comfort and reliability are turned inside out and rebuilt for the rigours of rallying. Of the 18 leading cars in the Monte Carlo Rally, 9 were built within 200 miles of here, drawing on a hotbed of technological talent. Every one is based on a mass-market production car, but the similarity is skin deep. X28 is the brainchild of David Lapworth, one of the most successful engineers in the sport.
The expertise is here, probably more concentrated here than in any other country in the world. We have a cross-section of all the Formula One teams within 50 miles of here. And in rallying, we have the Subaru team, the Mitsubishi team, the Hyundai team, all very closely congregated.
Major manufacturers come here in search of the science of speed. The technology in X28 is not built to last, it's built to win.
There's a huge amount of work to turn the road car into a rally car. They share the same genes, but the process we go through is extremely extensive. We almost redesign the whole car. It's a very specialised business in its own way, comparable with Formula One in technology. The real challenge is the sheer speed. It's hard for the average person to understand the limits that these guys take the car to. So everything is taken to an extreme in terms of performance and right on the edge of reliability.
7 a.m. on a freezing January morning, the Monte Carlo Rally begins, high in the French Alps. David Lapworth steps into his laboratory. For 3 days and 1,500 kilometres, the science of speed will be measured against the clock. This is the ultimate test of X28's technology. It must survive to the finish line and no further. And the first experiment is with an engine that will literally explode into life.
The risk of detonation is worse, yeah? So you need to be sure that Graham has mapped it, that it's safe at 20 degrees.
In the quest for speed, much of the engine has been built using aluminium, lightweight, but also fragile.
Every component on the engine ought to be stressed right to its limit. If it's not at its limit, it's too heavy, it's a handicap. We have to take it as close to the edge as the driver does.
Or maybe over the edge. Because this car is virtually a jet engine on wheels. It has an afterburner that will give it a baptism of fire.
So the engine, whilst it's based on the production cylinder blocks and cylinder heads, is quite a special item. A huge amount of work goes into special internals, special electronics. The sum total is something that starts off as 280 horsepower in the road car and goes to, all I can say is well over that in the rally version.
A rally engine needs to get as much air as possible into its cylinders, The more air there is, the more fuel it can burn for maximum power. High-performance road cars do this with a turbocharger. Driven by hot gas from the exhaust, a fast-spinning turbine sucks in huge amounts of air at the front of the car and squeezes it. The air is then cooled to make it even more densely packed and then force-fed into the engine. But there's a major drawback. It's called turbo lag. The turbine doesn't get up to speed until the engine revs up because it needs exhaust gas to drive it. So every time you put your foot down, there's a time delay before the turbo kicks in, which is fine if you're on your way to work. In rallying, there isn't time to hang around, but the solution wouldn't make you popular with the neighbours. Rally engines fire fuel directly into the exhaust, causing an explosion that rockets back to the turbocharger, tripling the engine's air supply. A rally engine goes with a bang. X28 does 0 to 60 in 3 seconds, twice as fast as a road car. But the engine's constantly on a knife edge. Its lightweight components are designed to last just a few thousand kilometres, and if they're pushed too hard, the whole thing could blow. During testing, each engine is run in at maximum revs to make sure it can survive a rally. Some never make it past the factory. At the Monte Carlo Rally, 2 cars have already blown their engines and are heading back to the drawing board. If X28's engine survives, it has a theoretical advantage over the other cars. It's the only car in the race with its 4 engine cylinders laid flat rather than upright. This gives it a lower centre of gravity, perfect for high-speed cornering. And the drive from the engine comes straight down the middle of the car like a propeller, making it easy to take the power to all 4 wheels. But only competition can put the theory into practice. X28 is in the capable hands of Finland's Tommi Mäkinen, arguably the greatest rally driver of all time. Co-driver Kai Lindström has detailed notes on every twist in the road, and at this speed, they come thick and fast. Lapworth and his engineers keep the car under the microscope.
We're sort of balancing the risks. The drivers do it all the time, deciding where to push and how hard to push. They're always taking the chance that they'll make a mistake and go off the road. And we're doing the same kind of thing. Should we take maximum risk and go for the win, or do we want to do something more conservative? So it's managing all those things.
The riskiest decision revolves around tyres. If Lapworth doesn't get it right, all the technology in X28 will be for nothing.
Tyres are the most underrated part of the equation, with the layman, and even in motorsport. No matter how much we spend on sophisticated control systems on the car, on special suspension and transmission and so on, the grip that's generated is through the tyre on the road. The performance of the tyre is absolutely critical to the performance of the car. So much so that if you take this tyre and swap it with the tyre off the road car, then you'll find that, if anything, the road car is slightly faster. So it makes or breaks the rally. You can win or lose according to whether you make the right tyre choice.
Don't experiment with these tyres on your own car. Racing slicks are incredibly smooth. There are hardly any grooves, so that as much rubber as possible can grip the tarmac. But slicks only work if it's dry.
Okay, in front of me here we have 3 choices. This tyre would be taken in pure dry conditions. It has an imprint in it, but this is just purely for regulation. You're not allowed to run a slick anymore. This is what they call a slick these days. The tyre next to it, you see, it has many more grooves in it. This is to help distribute the water out the side. This is called an intermediate, but this also has an extra cut in the middle between here. This helps get rid of the water. Now, this tyre here is purely for snow. You can see here, it has some metal studs in it which dig into the ice beneath the snow. Sometimes, for example, the cars may do a 20 kilometre stage. 18 kilometres it will be dry tarmac, but there may be 2 kilometres of snow. Now in this instance you take the slick because there's the 18 kilometres you're going to gain far more than you're going to lose over that 2 kilometres.
So the air temperature now at the moment is +8.
It's a guessing game.
Yeah. And
There's a
ground
chance of
is
ice,
+3.5.
but all the teams are going for the slickest rubber they can get away with. The tyres are stored in electric warmers beforehand. When rubber heats up, it gets softer and tackier, providing extra grip.
When you have a new set of tyres on, for the first kilometre, you have to be very, very careful. The tyre isn't up to operating temperature, and so therefore you have to allow for this in your driving. As the tyre warms up, then you start to feel you have full grip, and you have no problems then, and you can go as fast as you wish.
These tyres need to last just 50 kilometres, not 50,000. Getting the hardness of the rubber right is critical.
The softer compound. Medium soft or softer.
The trick is to try and choose the softest compound that will last the distance. If you misjudge that, then towards the end of the stage you lose a lot of time as the tyres wear down to the canvas. And if you choose too hard a tyre, then you just lose grip all the way through both stages.
Lapworth gambles on harder rubber than the other teams. X28 should lose time at first, then win it back with interest if the tyres last longer.
We think, at the moment, we've got it about right. We've got a medium soft compound, which we think will last the whole distance. So, hopefully, we'll gain a few seconds.
By late afternoon, things are looking up.
Tommy -8, Ronald -1, Harry +1.
Tommy's fastest so far.
28.
Tommy must be leading by 2 or 3 seconds.
Ron Holm, 17.
5, 3.
But now the ice comes into play.
Because Tommy has gone from +2 to -3. Tommy's probably had a half spin or something.
Just hope he's holding it.
Yeah, on the ice.
Bad luck, but fortunately there's no damage to the car.
Well, it sort of nearly went according to plan. Tommy was going very well on the asphalt section, and then unfortunately had a bit of a spin on the ice. So altogether we reckon he lost about 24, 25 seconds in there.
The long-lasting tyres have survived, just gaining back time on the dry sections. After 100 kilometres, X28 is still only 5 seconds off the pace. This is the last service before dark, and the tyres are not the only parts that need to be changed. The brakes are already wearing out. They work like a bicycle's. Inside the caliper, pistons push heavy-duty pads onto the brake disc, and friction slows the wheel. But a rally car has to brake from 150 kilometres an hour every few seconds. To handle the friction, brake discs have to be massive.
The brakes are much bigger than you'd find in a road car because of the abuse that they get from the drivers and the nature of the roads. The extreme condition is on asphalt, where there's lots of grip and therefore the drivers brake very late and very hard. So for a rally like Monte Carlo, the front discs are something like 370 millimetres in diameter. That's probably bigger than the wheels on most road cars.
Braking shifts the weight of the car onto the front wheels. The massive friction cooks the discs at over 600 degrees. The new discs are a vital precaution. In total darkness, X28 will cover 30 kilometres, just half a minute more slowly than in daylight. Day one ends with no further mishap, and the mechanics up sticks for Monte Carlo. The bill so far, 3 full sets of tyres, 1 new set of brakes, plus labour. But at least there's no overtime. Day 2. Of 18 leading contenders, only 14 are still in the rally. And the pressure is reaching its peak.
Let's stay with the bread, boys.
On today's mountain stages, the cars must cling to icy twisting hairpins at an incredible average of 90 kilometres an hour. The smallest mistake will launch the car into the abyss, enough to sort the sharks from the small fry. At this speed, no ordinary car could stay on the road. But X28 has a computerised traction system that in theory should keep every wheel pinned to the tarmac. If the theory's correct, then X28 will gain vital seconds. If it's wrong, the car could end up taking the low road back to Monte Carlo. The secrets of advanced traction technology can be discovered back in the UK. Because it's also contained in the car for Tommy Mäkinen's next race, the Rally of Sweden, which starts in just 2 weeks' time. Test drivers are already making fine adjustments to the car's traction control. A car loses traction if any of the wheels start to slip and spin too fast. But the rally car maintains traction on even the tightest turns because a computer is controlling each wheel individually. This is only possible thanks to the differentials, which allow the wheels to rotate at different speeds. When a car is moving in a straight line, left and right wheels rotate at the same rate. But when the car turns left, the differential allows the right wheel to spin faster to travel the greater distance around the outside of the curve. The left wheel spins more slowly. But there can be problems. If the rotation rates are locked together too much, the car will be difficult to turn. This is called understeering. Or if the differential allows the wheels to spin too freely, the car will tend to oversteer. Unlike a road car, the rally car actively controls the differentials and hence the speed of each wheel.
When it comes to competition use, where we've got generally a lot more power than we need, where there's the potential for lots of wheel spin, and as well as allowing the wheels to go at different speeds when we're driving sensibly, we need to be able to control those wheel speeds to divert the power to the wheels that have got the most grip when the car is being driven on the limit. So there's a slightly different role between the competition car and the road car.
The car's complex electronics contain sensors which can detect if a wheel is spinning too fast and losing traction. A computer linked to the differentials then diverts engine power to the wheels with enough grip to use it. The end result is that the driver keeps his foot down. With good traction, all the engine power goes into driving the car forwards.
That setup of the differentials is key to getting the car to feel the way the driver wants. The way we distribute the torque around the four wheels changes the balance of the car, and the forces that are fed into the suspension and into the steering give the driver a lot of input as to where the grip is, how close he is to the limit.
You're about to see X28 being driven right on that limit, with Tommy Mäkinen relying on the car to control the traction of each wheel. On this corner there's a tiny damp patch, but Mäkinen will take the car right to the edge.
Very smooth, the car just moving such a small bit there, just on the damp patch on the inside of the corner. Outstanding.
Technology like this gains only a few seconds, but it's enough to win a rally. In testing, David Lapworth often takes the co-driver's seat himself to see the fruits of his labour.
On a wide open road, it's quite easy to look at the way a driver's driving and see, the lines that they take when they get on the throttle and get a real feeling for each driver's technique. But on the twisty, bumpy section of road that we were going down with Tommy, there was a point where things were happening so fast, all I could do was sort of sit there in awe and sort of admire the speed that he was able to carry through the twisty section.
Man and machine are working in perfect harmony. X28 will enter the final day with a lead of 1.5 minutes.
Well, so far, so good. No, it's gone very well. There's been a lot of hard work. We took a big step forward about 12 months ago. We introduced a lot of technology, and we had 6 months of real hard work to try and refine it, to get on top of all the technical problems. I think we've done that now, and we're starting to see the rewards.
The true rewards will only come if the car reaches the finish line and wins. But X28 is about to enter the last day of its working life, and there's one last vital component which could fail at any moment. Within sight of Monte Carlo's famous casino, David Lapworth faces a gamble with the most valuable technology in the car.
The last day in particular is real nail-biting feeling. From the moment you wake up in the morning, you can't relax because there are decisions to be made, and also there are so many things that can go wrong. You have to be absolutely on the case.
X28 is reaching the built-in lifetime of its technology, and Lapworth takes out insurance. The single most expensive component of the car will be replaced now: the gearbox. Like engines, gearboxes must weigh as little as possible. They're designed to last for the duration of the rally and no more. Changing it early is an expensive precaution. Rally car gearboxes cost 60 times as much as road car models because they have to change gear 10 times faster. A rally driver hardly ever goes flat out in top gear on a straight road. Instead, he's constantly dropping in and out of lower gears to make sharp turns. He needs to get the gear he wants at the instant he demands it. In a road car, it takes half a second for even a top driver to change gear, using the stick shift and clutch pedal. For Tommy Mackinnon, half a second is a lifetime. He needs to change gear so fast you can hardly see it. The gearboxes that make it possible are developed at the team factory in the UK. And the secret is hydraulic control.
This is the gearbox, which bolts on behind the engine, and the power comes in from the front now. Inside the gearbox there are 6 ratios, 6 speeds, which are fully automated as far as the driver is concerned.
The gears themselves are set up something like the gears on a bicycle. The collars in between act like the bicycle chain, locking into each gear in turn. In a conventional gearbox, the driver has to physically shift these collars using the stick shift, but it takes time. In the rally car's gearbox, all the work is done for him at lightning speed. The gears are shifted hydraulically by internal oil pressure.
All the driver does is flicks a small paddle on the steering wheel, and the hydraulics for the gearbox change gear in about 30-40 milliseconds, which, believe me, is fast.
Inside a sealed unit in the gearbox, oil pressure moves a small pin that does the job of the stick shift.
Imagine you're in, say, first gear, for example. That will be in that position there. And if you want to go into second gear, it just moves it back like that, hydraulically. And then if you want to go into third gear, it goes into neutral, and then this needs to move, and then into your third gear like that. What happens, you can imagine this is moving very quickly, backwards and forwards with the hydraulic pressure, and it's like milliseconds for this to move.
At the test track, preparations for the next rally are almost over. This team were the first to introduce the so-called fly-by-wire gearbox, but the battle for technological supremacy never ends. An engineer tunes each vital component electronically, shaving every possible millisecond. But the ultimate test is on the road. In Monte Carlo, the new gearbox is already in position.
Come on then, come over, run up.
The engineer takes it through the same final tests. It passes. The entire gearbox has been replaced in just 12 minutes, and it could be a life-saving transplant. If X28 survives just 100 kilometres more, victory is assured. A car designed for this single purpose enters the last few seconds of its working life. Its turbocharged engine has almost survived 3 days of twisting mountain hairpins at an average speed of 90 kilometres an hour. It has worn through 10 full sets of racing tyres and a brand new gearbox. Now all it has to do is reach the finish line.
He's losing time. He's losing a lot of time. Oh, it's me. It's me.
Ja serpo vasen, 100 maali. Yes, yes, yes. No niin. Yes, yes, yes. Pitkä vasen eri plus. No niin, hyvä. Yes, kiitos. Onneksi on.
X28 has won the Monte Carlo Rally. Its mission accomplished, the car will be returned to the factory in the UK to be broken down for parts. But now a new story begins. 2 weeks from now, Tommy Mäkinen has a rendezvous in Sweden, and one more car is destined to be driven to destruction.